Hello, everyone. Welcome to the GR 101 Introduction to Grades. This is going to be a kind of an introduction to this next module. Uh, what you're looking at is the week one module, which everyone is almost through with. Monday, we'll get into week two, and that's what we're going to be talking about mostly for maybe 30, 40 minutes here, maybe a little longer. And we're going to talk about grade setting. Uh, so we'll get started. As you can see, we have finished most of this. Most of you have. Uh, and I would like to apologize for all of this delay in getting you guys into the course, some of you more than others, but it's just something that we've had trouble with on almost every start. I think we're going to have to get Canvas involved in how or why it's taken so long to get you guys in these courses. I'm hoping everyone by now has their textbooks. If you are required to have one, you're not required to have one in this course, GR 101. However, if you are enrolled in GR 101 as well as Introduction to Excavation, you have a book called, I think it's called Grading and Excavation, which has a lot of the same things in it as we'll be talking about here. Uh, so if you have it, that's great. If you don't have it, that's not a big deal because I use my own material mostly for setting grades. Uh, by the way, just so to be sure that you've done all of these things while I'm looking at it, there was a weekly overview, a course overview. I think I had a video up in the week one talking about the syllabus, uh, if I'm not mistaken, and I may not have. The course really didn't require a video, but it will as we move along. Each week we'll probably have one or two videos, and I hope to get in uh, a Canvas big blue button. So if you haven't looked at that, that's instructions on how to use big blue button. It's just like Zoom. If you've done a Zoom, it's basically the same. So we may need to have one of those as we move forward. I think we have probably 8 somewhere along there enrolled in this class, which is good. Make for good discussions. Uh, and certainly, if you have questions about this uh, tailgate deal, I want to go over that again with you in this video because it's easy. It can be very, very useful. It can be a little bit fun, maybe, but it's up to you, on how engaging you make it. But there are some requirements, and I have a few of those requirements uh, here that I stuck in that level one, and I'd like to go over them again uh, just so you know. Uh, Tailgate, of course, came from for those of you that's had jobs in construction, every morning you get together around the pickup and you talk about safety issues, what's going to be done for today, things to look out for, power lines, traffic, etc. All of the things that have to do with that upcoming day are usually gone over with by your foreman, supervisor, or someone just to keep you uh, wound tight, so they used to say in some circles, uh, but on your toes. So I need 3 responses. It's going to be tough in excavation to have a good, for those of you here that are also in excavation, we only have 2 students over there, so I'll be involved in your discussions, but we'll get through that. So let's just look at this. Says you're required to make an initial post, and right here, your initial post must be submitted by 11:59 midnight, I guess, Central Standard Time on Tuesday of, well, it'll be next week. We'll be in a different week. But, and then you also have to respond to another student. It's called your first response of two replies to a student must be submitted by Thursday midnight. Now, your second response, that's to another student, or the same one if it makes sense, if you didn't finish what you said, needed to say. So your second response is due by Sunday. And there is, I think I said it like, I don't need all these absolutely kind of adverbs, but one thing that I don't want is a late Sunday night response just before 11:59 p.m. And that's for the other people, the benefit of your cohorts, your fellow students. If you wait until a minute till midnight, see, they don't get to see your post. You're out of there, and they're lacking one student that they could respond to. So, sometime before midnight, I need you to get that Sunday response in, but don't wait till the last minute. Let's see. Uh, Note that these are minimal responses. That It's just like, here's what you at least need to do. But if you want to have a discussion, there's enough people now. We could get a really good discussion going, I think, and probably some various experiences in your. Some have been in construction, some of you, but it doesn't have to be just like if you haven't been in working in construction. Maybe you just got out of a certificate program like mobile crane, or heavy equipment level 1, 2, or used to have a 3. And you can talk about that too. And there may be others in this discussion that have gone through certificate programs. One thing you need to know is you're not going to get to see the other students post until you post your first reply. So, and that's not showing up in the tailgate overview. But when you get into the tailgate, you will look down in this area of the tailgate, and there will be the word reply, and you click that and put in your uh, initial post. Uh, we may talk about the week 2 tailgate when we get there here in just a second. I need to move on. I got a lot of ground I want to cover, but listen, this right here, you need to know how I score this. Your scores are based on timeliness, like this. Your scores are based on intellectual engagement. In other words, are does what you're saying have an effect on anything? This is not idle conversation. It needs to be a little bit in depth. Uh, One-liners won't get it. I like your post won't get it. You need to include why you like what your fellow cohort said. So it's not like you just uh, trying to figure out 100 different ways to say I like what you said. Just say I like what you said and here's why. So I will grade it on sentence structure. You know how your sentences are. There are a lot of folks that I've had in the past that have like over 170 something words, honestly, in one sentence. You have to give the reader time to get their mental breath. In other words, let them stop it with a period, take a pause in your writing, and they can take a pause in their reading. Commas are not a substitute for periods. Commas are like you use when you say however, comma, and then blah, blah, blah. Uh, you don't have to be perfect, but you have to be working toward proper grammar and sentence structure. Uh, the content, what you're talking about, will make a difference. Usually we'll stay on something close to subject matter, but in one case, I don't remember which course, it was talking about self-advocacy, speaking up for yourself. And there may be some things that I want you to talk about that are course related. So if the maximum score you can get on your initial response is 35. The minimum score is 0. In other words, if you leave it out, the maximum score you can receive for your second response, if it lives up to all of my expectations, intellectual engagement, sentence structure, etc., the maximum you can get is 35 points. There's 70 right there. Now, if you forget this one, which has happened on many occasions, if you forget this or just decide you don't need to put it in there, this is worth up to 30 points. So right here, and out of 100. So right here, you have a chance to make 70 of those 100 points. But if you leave this out, your score is going to be 70. If you did these, you scored the maximum on these two responses, your initial and your first response to another student. So keep that in mind. I have a rubric. I'll put it up. I can't do it right now, but it shows you a little bit how I do gauge these things. Now, sometimes I will change my mind and I will let you know in the instructions. We're going to do this in a different way. This is going to be like an essay assignment blended into your discussion. So there will be specific questions to answer, and I'll probably waive the this initial post, first post to another, and second post to another student. But I'll let you know those things. So moving on. Can't move on yet. Yes, I can. I'm going to get back out so I can look at all of the whole thing, kind of fly over here before I leave it. This is your quiz. I've already got a lot of these turned in. I'll have those graded. I always wait till probably Sunday or Monday before I grade because I'm not sure you're through. Like you may fly through there at noon or something and do one of your posts for the tailgate, and I might, and you may have one other post, and I'll say, well, I guess this guy, forgot this student may have forgot his last post, so I may only, I got to wait to give you plenty of time. So sometime Monday is usually when I'll start putting up grades for your assignment and your discussion and your quizzes. Uh, we had a submission practice, hadn't had a chance to see how y'all did on that. You got 100 for trying, but if you're having problems on this, you need to let me know on submitting uh, to Canvas your answers or whatever you need to submit. And many of you have completed this pretest. Of course, you get 100 points for just doing that. And I'm not worried about your score. Uh, I suppose you'll get a score, but not to worry. You're not supposed to know a whole lot about it. That's just what we're required to do within our accreditation. Is we have to do a pre-test to see what you knew when you got here, and a post-test to see if you learned anything. Hopefully, you have when you leave. Okay, this is when the work starts right here, and as you can see, these are structured, and it's just like in all of our courses, this is what you're going to be when you go to the next course. You're going to see this, but there'll be different kinds of material in here. So we don't want to change this. We haven't changed it, and it seems to work well for all our students the way we have it set up. If you have complaints about it, we'll listen to them and we'll give it consideration. But this has been working well since we started. So let's get into the meat and potatoes of this thing right here. I think uh, usually I may sometimes have a video here, but for this week, we want to know what grade and elevation is. What does that mean? What does grade mean? We want to demonstrate an understanding of the engineer scale. A lot of you guys may not have used an engineer scale, like on a ruler. You may be used to feet and inches. Well, we use feet and tenths of a foot. And, like 3.1 is 3 1/10 foot. Not a difficult thing to understand, and it's a good video, and we can talk about that. But so that's one of the objectives, is to know how to do that. Basic stake marking. I need you to understand the basics of how to read and how to mark a stake. I need you to be able to measure something horizontally. Most of us may have done that, whether it be feet or inches, or feet and tenths of a feet, tenths and hundredths of a feet. You can think of an engineer scale as like $1.50 is a foot and a half, right? 1.5 feet. Okay, so I want to still get back so I can see the whole module, and then we'll move from there. Okay, terms. So we looked at the overview. I want to start. This is starting let's say the class for uh, one class for this week. So I put a bunch of terms in here, and I got to thinking, I never have done this before, and it's just like we kind of learned the terms as we along the way. But I decided to put these terms, and I'm not going to spend very much time on them, but you need to read them, and if you can, and try to understand them. This may be the first thing you've ever seen about grade reading. If that's so, that's going to be some things in here, probably even with the definitions, that you don't truly understand. But a control point is a point set by a surveyor, and it's like you measure from that, whether it be a horizontal measurement or a cut and fill measurement, up and down measurement. That's set, and there's several of these set throughout the site. Now, they use what's called a hub, and that's like a 2 by 2 inch stake, about 6 inches long and driven into the ground. The center top of that hub uh, will have a tack, and use that tack to measure horizontal distances from that point, and you set your grade rod on top of that hub, and that's your your vertical measuring reference, whether it be up or down in a cut, which goes down in the ground. Now, a crow's foot is a line drawn on the stake. It looks just like this right here, and it takes the place of this hub driven in the ground. It too becomes a reference point if you don't have any hubs, so all measurements will be taken from this point, especially in vertical. For fills, you would put your grade rod right at that line, and to measure up, and to measure how far down you are, you would put your you would measure I can't get to be still. You would measure from the line under what looks like a V uh, down, to see if you were on grade or not. This will become a lot more familiar as we go along. There's a hub. I've described that. Grade is the elevation to the top of a fill. If we add dirt to bring the grade up higher, or it's the elevation down to the bottom of a cut, the bottom of a trench, let's say. Those will all have grades, and grade is based on sea level, how many feet above sea level. We'll get into what we call arbitrary uh, benchmarks, like you start a pretty simple site. You can just drive a stake in the ground, and call the top of it 100 foot, and then everything will be relative to that, if it's not a complicated uh, site that you're staking out. So, and that will become clearer as we go. Now, I'm using the word stake a lot, but some people call it a lath, and some people distinguish a stake from a lath. But these are just stakes with information written on them, usually with a felt tip pen. And as you'll see later on, a ribbon is tied in some cases just so you can use what's called a hand level to sight in on the mark on the stake. So we'll write either cut or fill and or offset so many feet, and we'll get into all that. And speaking of offset, right there it is. This is the way you would write offset on a stake, and it's a reference stake that provides a means to have necessary information like elevation, station number, grade, slope ratio, etc., close to where the work must be performed, yet out of the way of the work done. Like if this set offset 5.0 feet, everything this stake is talking about would be 5 feet away from, would start 5 feet away from that stake. So original ground is existing grade, existing ground. It's the way it is when you get there. And when we get there, our job is to change it to the way we want it to be. Percent is a means of defining the steepness of a slope or the rise and fall in grade relative to the horizontal. In other words, the horizontal is just like the horizon that's level horizontally. Uh, Now, if we have a gravity flow, let's say coming from a house, usually your your drain line from your sink and all that comes together in a bigger pipe underneath or in the slab, and it's laid in there at a slope, maybe 1%, so if it was 100 foot long and it was falling at 1%, when it got to the other end, it'd be a foot lower. So we'll learn how to calculate those kinds of things. A profile view is talking about a view of a vertical section of the ground. It's used to show the relationship between the existing ground line. You know, it's just like you have a loaf of bread. Well, if you slice that bread like where the heel is, it's sliced, right? When you get it out of the store, you remove that heel, and what you're looking at is a cross section of that loaf. Now, if you get one of those Subway sandwiches freshly baked before they cut it, and you lay it like a hoagie thing, you lay it on the table and you don't cut across it, but you slice right down the middle of it and you open one side of it and look at that, that's your profile view of that loaf of bread. So consider a highway. It's, if you see a profile, that means that right down the center of the line, they've sliced that highway, and what you're looking at is what's underneath that highway. And this will begin to make sense as we move along. Also, uh, the grade boot. Now, there's two things right here. I put them close together. There's a what I call what is called a grade boot. You will see the term hike up used in lieu of the grade boot. Now, these two things work together. So the boot, I defined it. I don't know if I made this up or got it somewhere, but my definition of a grade boot is an arbitrary line marked on a grade stake establishing a known height above the desired cut. It's mostly used with cuts. Uh, I want to take that back. You'll see more grade boots used with cuts than fills, but it's not exclusive to a cut stake. So if you can imagine, I don't want to get ahead of myself, but it's to help you as a grade checker using a hand level not to have to lay down, or there may be something in the way of where the grade line is marked on that stake that you can't see it. So you want to establish a grade boot. Let's say you have a grade boot and you want to put a grade boot on a stake that reads cut 5, I'm sorry, cut, yeah, 0.5 feet, you want to go half a foot down. Uh, Then you want to put a 4-foot boot on there so you can raise it up on the stake. You would take 0.5 and subtract it from 4, so you would measure up on that stake 3.5. That would be your hike up. That would be where you put that 4-foot grade uh, boot. So, no, not going to get into it right now. I know it's a little confusing. Just hold on. I didn't finish reading it here. The grade boot is used in whole feet, such as 5, 4, 3, 2, and 1, and is chosen arbitrarily by the grade setter. If the grade setter chooses 4-foot grade boot, has a cut of 2.5 feet by subtracting the boot of 4 feet minus the cut of 2.5 feet, the high cut would be set at 1.5 feet above the crowfoot, and therefore 5 feet down from that mark would be grade, even though you're not there yet. You can you will get there, and on the way down you can take shots at that grade boot and let your operator know how much further down he needs to dig, trench, or grade with the dozer or motor grader. So those are the terms I set up to get us on the way. Let's see if next is I want you to read this. It's safety and mental condition. Can't never you know, you can't overkill safety. It's consciousness of the potential hazards around you. Also, it's your PPE, and it's your what would you call the your can't think of the word, how far you're spaced away from other pieces of equipment. You know, don't walk behind a dozer when it's backing up, et cetera, et cetera. So we'll get into a little bit more safety as is specific to what the course is about. This is a story about a guy. This is years ago. I know it because my work is years ago. So this guy, I think, I'm not sure, but anyway, he was inside the bowl of the scraper or paddle wheel scraper, and I think he was welding in there or something. But at any rate, the guy operator runs and jumps in the scraper, cranks it up, takes off, turns on the paddle wheel, and the first thing he sees is pieces of the guy's clothes sticking up out of the load that he had just dumped. So it just kind of chewed him up, I guess. So you read it if you want, but it we want to be safe. This is this is grade. The term grade has several meanings. The elementary definition is just to give you a basic understanding of the meaning of the term as it's used in the early part of this book. An equipment operator who calls for grade merely wants to know the location or elevation of an established point, such as the top of the fill or the bottom of the cup, and where it may be located in reference to another point. So here is like, let's say this is a slope. Well, the way you build a slope really is like they're showing, only this, imagine this would be three-dimensional. So at this elevation, he's 1,250 feet above sea level. Now, where do we get these elevations, you know, of 1,250 feet? Well, Oklahoma City is in the 1,200s. And when they build a bridge or something like that, the government, like the USGS or one of those geological kind of under National Oceanic and Atmospheric Administration, has a bunch of agencies, and one of them goes around and sets permanent uh, benchmarks that have the elevation. Like maybe they build a new bridge, well, they may put a medallion on the rail of that bridge and out of brass so it won't rust, and it'll have the elevation of that rail, so you can use that to start and transfer grade called differential leveling. We'll also get into that back to your job site. Now, the grade here is 1,250. So the grade here is what? 30 feet higher, right? And so on, and so on, and so on, and so on. So they cut this out of an existing grade here. And here is another, here's a fill. They had to fill it up, and then they started this fill, I'm assuming, is at 1250. And so they started cutting and into this existing hill, moving three-dimensional. It would be the X, Y, the Z axis. These things are going away from you. They're not going that way. The slope is that way. If you drew a perspective, we'll have one of those later on. You can see it better. So that's great. Read all of this. I don't want to just read it for you. It takes up too much time. I want you to read all of this. If you have any questions, of course, you can get in touch with me. But I want you to go through this like old school stuff, you know. And once again, same with cranes, you know, there's not really nothing has changed since they built the pyramids. The principles are still the same. Leverages, you know, force multiplication by using leverage, you know, all of that's still the same. Well, let me tell you something. All this GPS and automated grade control, that's all based on what we're teaching here, and that's why we're teaching it. When you have this background or foundation, your transition to automated grade control is going to be basically just learning how to operate the telematics or whatever it is that you're using uh, at that particular job. This is a hand level, and you'll see a lot of superintendents and foremen carrying them around, and they're checking their GPS stuff with it. You know, this is used in conjunction with an engineer's, one of those folding rulers that everybody used to call a carpenter's rule. It folds out to 6 feet. Well, you'll have, or you would need one uh, that has on one side the engineer scale, on the other side maybe even has the inch scale, the foot and inches scale. But they all look like this. They're telescopic to an extent. There's a bubble here, but there's a 45-degree metal mirror in here. So when you look in here, you can see that bubble moving. The bubble's actually moving this way, but you move your level up and down to get it level. So here's what it looks like he's shooting. This is a crow's foot for a fill, it looks like. Not because it's pointed up, it's just because it's so far above the ground. I'm saying a fill. When you look through there, it'll be round, but over here on the left, this will be your bubble, and it'll go up and down until you get the center line of it, and you'll be able to tell that, and that line right here is adjacent to this line. And then you would take your reading off of the engineer's rule, which you are holding in your hand. Now, here's a way not to do it. And this is telling you that it's level. This is telling you to tilt down. If you tilt down, that means you're going to get close to more level. And when you're moving up the engineer's rule, you want to look at the same time you're moving up, because you can see the stake mark coming into view. It's just like you got to go up and down until you have it level, and then take your reading. You can see a guy holding it. Most people want to get right behind the thing and squat down, but you can't squat down low enough, you know, so you get wrong kinds of reading. You need to kind of kneel off to the side of it, and that lets you go lower without having to lay down. You just kind of lean over, and that's enough of that. Let's see if we can, what's next here? Basic stake marking. Look at the figure first. Uh, you can read this stuff if you want, and I'll probably go over some of it. Uh, the stake on the left, as you're looking, says cut 3 9/10. It's written like in superscript, like the 9 is a little bit smaller than the 3, and it has a line under it. Why don't we just say 3.9, 3 9/10? Well, The dot may confuse the grade checker, and he may think it's cut 39 feet. So it's, I'm pointing to it up here. See, this 3.9 means 3 foot 9 tenths. Always underline tenths, otherwise the stake could be misread as cut 39 feet. And there are 39-foot cuts on a lot of excavations, especially the ones that have slopes on them. So that's the way you write it. Over here, look, this is the proposed grade. This stake has a cut from here down of 3.9, and then it's good. This one has a cut 5.6, and when you, there's the hub in the ground right there. There's the crowfoot that you're measuring from. So this one has a cut of 5.6. The cut here is deeper than the cut here. Why is that? Well, look where the grade is in relation to where the existing grade is here, and here it is here. Here's your grade here. So over here, when you're measuring from here down, it's not going to be near as far as from here down, right? Right. You're going to have to go further down from this grade line. This is grade. And you'll want to go 3 9/10 down from here to the proposed grade. We're both going to the same place. We're just starting from different places. We're starting from a higher elevation here going down. We're starting from a lower elevation relative to this elevation going down. So this cut's not going to be as deep as this cut. Field stakes are designated by the letter F, and they're written on the stake. The numerals that follow the letter F indicate the amount of earth needed to bring the existing ground to the proposed grade and is measured from the horizontal line of the crowfoot mark. The V part of the crowfoot is used to clearly establish it as the reference grade. And it doesn't matter in what direction. Just because it's pointing up doesn't mean it's a fill. Because it's pointed down here doesn't mean it's a cut. It's just pointing out this is your reference line. This is your crow's foot. Now look here. This one has a fill of 6 8/10. Now we're going to the same place up here. This is where we got to bring dirt in until we get here. So the stake here is going up 5 3/10, but the stake here is asking us from the reference stake to go up 6 8/10. Same deal. That's because we're starting from a lower point going up. So we got to bring more dirt in to get all of this filled in too, to get up here. So we got to fill from here would be higher from here, than from here relative to the existing grade. That's why the difference is. On grade stakes indicate that the ground is where it's supposed to be. Here, it looks like you might want to bring in a little bit dirt, but basically, these would be level when this one says grade and this one says grade. So this one probably wouldn't require anything. It depends on your tolerance. You may want to bring everything up to the level of the grade mark. This is just how to, the other thing you mark with, nobody, I say nobody, no telling, used to use those lumber crayons like a big Crayola, but the felt tip is much easier. And notice how clear cut, and this is the way you write on a grade stake because you don't have much horizontal room, but you start with cut 5 foot 0/10. That line is under that little zero, so that's 5.0. That's 5 foot even. Here, he's put a little grade boot in at 1 foot that I was talking about, and he's going to tie a ribbon around it because if he used his hand level to shoot here, he'd have to lay down. I would have hiked it up 2 feet, even that way. He may have to get down real low even to see a 1 foot boot, but he has to take his reading right here and then subtract that grade boot, and that way he'll know what what it needs to read 1 foot. If he's off somewhere trying to shoot this from over here somewhere and he can't see it, he shoots this and it reads 5.4. He needs to remember he's down here another foot, so it's really 3.4. It's like a vertical offset. This may clarify it a little bit better. Talks about 25 foot away, because that's usually the maximum range, let's call it, of an accurate shot with a hand level. So when you have an error, usually using a hand level, it's just going to be because it wasn't level or you didn't read it right when you shot it. I don't think it says it may be driven into ground, talking about stakes, usually after it's driven, because once you drive it in the ground, if you wouldn't know where to mark these before you drove it in the ground. You would have to have the stake in the ground so you could measure up where to put the hike up and so forth on there. So let's see what is next. I like this little video. I'm not going to spend much time here. Most people can get by this. The reading is really small for me, but it's talking about the example one is express 5.56 inches in feet. So 5.56. What is that in, if I wanted to convert hold on, if I want to convert inches to feet, I would need to divide 5.56 inches by 12, and that would give me 5 and 9/16 inches, basically. That's the conversion. See, 5.56 divided by 12 is 0.463 feet, which is close to 9/16. So that's your conversion. If you want to convert feet to inches, if it was over here, like using this is, here we go. Here's 0.1, 0.2, 0.3, 0.4. Now everything past here is going to be 1 point something. This is just starting at the bottom, so it's 0.1 feet here, and here this is hundredths, so it's 0.15 feet here and on down the line. So if you look at, once you see this video, it's really good. It'll be this right here it's in red like on a grade rod. He knows it's 4 feet. The beginning of this ruler is way down here. I'm not going to sit here and watch the video with you. I want you to watch it, but it's a really good, quick, brief explanation of what I'm trying to explain over here that's hard to read. Read these. I can't. I have to get real close, but you can read it to see, because they go through some examples here of conversion. But this will be where his point is. I don't know if that's a 9 or a G, but if you're here, if you're in the 4 foot range, and that's what he's telling them, this will be 4.9. Yeah, that's what it's got written. Feet. 4.9 feet. 4 point. Yes. I'm hesitating because I'm trying to see why he's. Yeah, so this is This is not back this way is the 4. He just showing him in the 4-foot area. I don't know about this being here. I think this is 4.09. No, 4.09 would be here. So that's 0.9. So this is 4.9 feet, just like he said. I'm sorry, didn't mean to confuse you. Just challenging it a little bit, but I get what he's doing. He's in the 4-foot zone, and he's right here. He's at 4. When I know the error is over here a little bit, but the tick mark that's under that 9 is where the 0.9 is, 4.9. So if we have troubles, shoot me a phone call or an email. But I think once you see this, you will understand it. Let me see what's next. Vertical measurements. I think we've been going for 30 minutes. I'd like to go through this. We probably will have to revisit this again, but I'd like to get through this vertical measurements section. And then the next video we'll talk about the boot, the grade boot, because it comes in use usually on vertical measurements. There's only 2 directions of measurements for a grade checker: measuring across the ground horizontally from one point to another. That's the horizontal measurement. And measuring straight up and down is the vertical measurement, and that's the one we're going to talk about. I'm going to continue to read. That's okay, because I want to make sure I cover everything. In order to transfer grade from an existing known elevation, which is here, to an unknown elevation, which is here where his hand level is, use the horizontal line of sight through the hand level and the vertical measurement of the 6-foot engineer's rule right here. Vertical measurement of the 6-foot engineer's rule. This principle is illustrated in figure 19, and that's what we're looking at. Now, just for instance, I don't think they have a for instance, but I'm going to give you for instance. This is the existing ground, and it's on grade right here. Now, this is the engineer's rule that goes from 0 in tenths and hundredths of a foot all the way to 6 feet. So if he's reading, let's say, exactly 3.0 feet, when he puts his stake in the ground, this is not the stake, this is the ruler. What is he going to write on that stake? This is going to be, is this going to be a cut, or is this going to be a fill? This is the grade we want to have. This is the grade that we have to begin with. So he's shooting at the grade we want through here, and he looks on his ruler, and his hand level is sitting at 3.0 exactly. What goes on the stake? Fill, 3.0 feet. So he just transferred grade. Now, does he mark his crow's foot here? No. He's going to have to mark it here. So he's going to have to know this is 3.0 even to right here. So the distance from here to here will have to be measured. He can draw a line right here. And the distance here measured up to here, let's say he read 3.0, but the distance here is 2.5. He would have to put fill 0.5 feet to be at the grade he wants. See, he pulled this grade over by looking at it. he drew a line, and then he took just a tape measure, if you want to, and or looked at his ruler on the stake and measured down, and it read 2.5. So he's 2.5 feet off the ground right here. So if he shoots this and it measures 3, he needs to fill 0.5, because this grade, according to this ruler, is 3 feet higher than this ground, and he's got to get to this grade right here. Say it again. All he knows is that this is grade. Says so right here, grade, and it's got a crow's foot right here. He takes a shot, and it reaches 3 feet. So that tells him that this right here, from here, well, let's say from here, this is 3 foot higher than here, because this is 3 foot. It doesn't, if it read 3 foot, he would be on grade right there. But if he puts a stake in, right, and it turns out to be like from here down to the ground, and it wouldn't, but the simple way to look at this would be to get to here from here is going to be 3 foot. But you know that whatever this is on the ground from here, this point to here, is 3 feet. Now, if it's any different from over here than 2.5, you're going to have to take that into account. But from this point to here is going to be fill 3 foot. I know you probably have questions, but I can't answer them right now, so write them down, so next time we come to this and we will revisit this, you will have them all written down. And it talks about the angle that you're looking at. I don't want to leave this. I felt like I've confused you. Whatever, in this case, whatever this engineer ruler reads right here is how much dirt is needed in here. So when he marks that stake right there, that's grade, and it should be. If he's reading 3, that should be your grade. So you gotta fill it from here to here. Now that's where I'm messing up. If this like this ground was lower and it measured 3.5, the fill would be 3.5. I think I've complicated it, but perhaps I can straighten it out and say, let's say this ground went down lower than that, and this turned out to be 3.5, he reads on here. Well, that would be a 3.5 fill. Let's move on, because we've got more and more of this. Here's the same thing going on, only it shows the lath, or the grade stake. It shows the engineer rule, shows the guy looking through the site at that grade point. Now then, look at this. This has a cut thing here. So from here down to here needs to be a cut from here down up to an 8/10. Now, look at it over here and think for a minute. What is he reading on that grade? It's telling you right here. From here to here, that's his reading, because this is the bottom of his engineer's rule. This tells you he's reading 2.7. Well, he can draw a line there, And that will be this grade, but this is not the proposed grade here. This is his line of sight, right? So if he reads 2.7, what does he need to read? This is what he needs to read because this is the proposed grade. He needs to read 2.8. He can put his grade mark because we just pulled it over. But what do we have to do? We have to go down 2.8 from here. So right now, he's down 1.7, and you take 2.8 where he needs to be, minus that is 1.110. So what would he put on the grade stake to get him to reading the same here? He knows this is what he's got to have, because from here down it tells him it's going to be 2.8 down. Now, wherever you are, you need to be 2.8 down from this elevation right here. So right now, you're 1.7 feet down from that elevation. Now, if you go another down, another 1 1/10 foot, you will be at 2.8. So on the stake, you need to write cut what? 1 1/10, because this distance down is already down 1 7/10. But he needs to be down from here 2 8/10. So he's got an additional 1 1/10 further down to excavate. Do we have a different one? Yeah. We have here, we have a, whoop, hard to get it centered. We have a cut here also from this point. Now, he can, I use the term, pull this point over to here using his engineer rule and make a mark. Now, that mark he made is 1 7/10 higher than this, right? So from here down is 1 7/10 lower than this, but he needs to be 2 6/10 lower than this, right? So he needs an additional 9/10 to go down, which would put him to 2 6/10. So what goes on the grade stake is cut 0.9 feet. That'll put him 2 6/10 below this elevation, according to this, where he needs to be at this elevation. Again, this is line of sight, these dashes. This is proposed grade. So in this case, it would be an addition. He's got to go down. In the other case, well, it was the same thing, 1 1/10, put him at 2 8/10, because that was the cut. So let's try one more. Let's read what it says. This right here is telling us here, or how about a field situation? Here we go. Figure 22 shows up. I think we had one of these. A field situation, how to measure 3 2/10 above the ground if the proposed grade was 1 3/10. I think that's just making an example here. Let's use this and stick with that's just a practice. It's showing figure 22. Sorry. Look at this. It's explaining this, but I'll just do it from here. This is a fill situation. From here, according to this, from this point to the proposed grade, which is bringing in dirt to fill it up to this point, I don't know for how far, but he needs from here another 1 5/10 of dirt brought in at this level. Okay, so here's our stake, and here's our line of sight. From here over here, this tells you what the rule would read. It would read 1.7, but if he drew a line here and measured down, he would measure 1.7. But because his ruler's sitting on the ground, he knows that from here to wherever he marks this stake right here is 1.7 above this location. But this is a fill of 1.5. So this right here is not grade. This right here is not grade. This is grade, which is 1.5 or 1 5/10 feet above the crow's foot. Needs this much more dirt. So what is he going to put on this stake? Well, he's got to come up this far, and he reads that at one, or measured it, is 1.7, but he still needs to come up how much further? Well, it tells you right here, 1.5. But if he from here up would be what? Fill 3.2. That's what goes on the stake, because there's no dirt here yet. So we have to measure from the existing grade up this far, which puts him even with the starting point here. But it's saying I need another 1.5 feet here. So from here up would be another 1.5 foot. But he's got to write on the stake from this point down here, fill 3.2. And then that will get you there. Okay. This is the grade boot, and this is where we'll stop. We've been in it for a while, and let's stop, and when we come back, we'll take up at the grade book. Read ahead if you want. That's fine with me. See if you can figure these things out. But we've covered quite a ground and got quite far. The next thing we'll do is deal with the grade boot and the high cut. So watch the video, and see you next video.